Did you know, back in the long, long ago time, that people distributed software for home computers on these? Well, one of the things that got distributed on FlexiDisks was Southwest Technical's 4K Floating Point Basic. And we're going to take a look at that today on...
Hey kids, it's the 6502 show.
In the nascent days of the microcomputer revolution back in the mid-70s, there were all kinds of ways to keep you from having to type in row after row after row of hex data to get a program into your computer. There was, of course, paper tape. There was cassette tape. And disk drives. Of course, no one back then who was a hobbyist could afford one. But then there was also something called the Floppy ROM. It didn't last very long, there weren't too many of them made, but it was an attempt to get programs in a simple format that anyone could quickly load into their machine and not spend hours and days typing away and certainly introducing mistakes. The idea was to take the audio that normally would have gone onto a cassette tape and feed that into a record cutting machine that would give you a master, and then you could print out the floppy ROMs. This wasn't something new. It had been done since the 60s. The Beatles did this for their special fan club Christmas giveaway. They did that for years. So this technology could be used also to put data onto a vinyl disc. And in the May 1977 edition of Interface magazine, Interface Age, this was done. And the first program to appear on a floppy ROM was Bob Uiterwyk's 4K Floating Point Basic for 6800 microprocessors. This had been tried a little earlier to put some programs for the Intel 8080 on, but it didn't work, and it's because they were using an intermediate process. The thing that the fellas at Southwest Technical Products were able to do was they hooked up their AC30 cassette interface directly to the recording machine rather than using an intermediate type of thing where you took a cassette that you made, with your interface, then fed that into the record cutting machine. So by going directly in, they removed dropouts and such things and got a format that was reliable. So for the next couple of years, Interface Age distributed software this way. As far as I know, 5 floppy ROMs were published in the magazine and pretty much given away for the price of the issue, which was only $1.50. So you got great software for the price of the magazine, which you were probably buying anyway. The only other floating point basic that was available at that time for 6800 machines was the MITS Altair 680B Basic, written by the young fellas at Microsoft. MITS and Microsoft were charging between $200 and $300 plus, depending if discounts were applied, for people to buy a paper tape copy of their floating point basic. In the May 1977 edition of Interface Age, William Turner and William Blomgren explained in an article how you would hook up your record player to your cassette interface and get the thing into your computer, and then you could save it to cassette. And the story of how they did it was completely recounted in the magazine and later on in the Best of Interface Age, which had a number of basic interpreters in it. Well, let's listen to what the Kansas City Standard actually sounded like on the floppy ROM. I pulled this audio off of a YouTube video, and a couple years ago, a fellow named Experimental Records kindly posted this onto YouTube. But rather than go through the machinations of trying to extract real data out of this audio file, I just went over to D-Ramp, and he's got a copy of 4K Basic just waiting to be had. All right, let's take a look at some of the features of Southwest Technical Products 4K Basic and what it claims that it does well. This here is version 2.0 of the program.
All mathematical operations are performed in binary coded decimal for maximum accuracy. And that is going to be a little more accurate than binary floating point, as we'll see in some benchmarks later. You can save and load. Many function subprograms are implemented. Well, not so many. Statements can be executed in direct mode, will run in a small amount of memory. Users can call machine language programs with the user function. Well, yes, that's true, but you're not going to be passing any data between the BASIC and the ML subroutine. It's just going to be much too difficult, especially without any ability to put results into variables easily, or without peek and poke statements in the BASIC. Here is the instruction summary of Southwest Technical Products 4K BASIC. And we can see there are a few things you're not going to find on most BASICs. The patch command and statement send you back to the monitor, in this case MICbug or SWTPBug. And you also have read data restore, which is wonderful to have. I mean, that's a big plus. You can dimension variable array, very handy. You've got onGoTo and onGoSub, very useful, cuts down on some programming. As far as the functions go, well, you've got what most tiny BASICs have. The real addition here is the character string function. So you can output a character by its given ASCII number. There's tab. There's user, and as I said, it's not all that useful because it's difficult to pass information to and from the ML subroutine. And you've got your usual math operators, your relational operators. Line numbers can be from 1 to 99. You do have a larger cache of vegetables. You do have a larger cache of variables to work with. You'll notice that it can be a single character or a character followed by an integer of 0 through 9. So that's pretty cool. That just vastly multiplies the amount of variables you have to work with. Okay, now that we've seen the specs, let's put it on the road and give it a test drive. First, the good old Sierpinski carpet, and we'll test 4K floating point BASIC against TSC's 10K cassette BASIC and MITS Altair 680 BASIC.
Look at TSC 10K BASIC go. This is going to be our winner. Not too far behind is Altair BASIC 1.1. And on the right, we have Southwest Technical Products 4K BASIC chugging along, doing its best. It looks like the carpet is halfway printed for TSC. And we're just approaching the halfway point now with Altair. MITS Altair BASIC. All right, here we're coming into the finish. And we have a winner at 49 seconds. Here comes MITS Altair, obviously in second place. And a final time of 67 seconds. Now, in the interest of not boring you to death, let's speed this thing up just a little bit. Now we're coming into the home stretch. Ready to cross the line is Southwest Technical. Boom! 356 seconds. Truly a modern marvel. Okay, here is David All's simple benchmark from back in 1983. The closer you are to 0, the better. And also, with this formula, the closer you are to 0, the better. Now, that's just all fine and dandy, but this is going to present a problem for 4K Basic. So what we're going to do here is create a subroutine in Basic that will give us the square root. And 7 iterations is pretty good for about 6 decimal places of accuracy, which is pretty darn fine. That's going to be great for us. The problem is it is Basic. It's not machine code like calling the other function, when you have that function. And yeah, we could write this in 6800 machine code, but we could call it, but we'd have no way to move the data to it and back. So this is what we got to do, and it certainly explains why this thing takes over 18 minutes. As you can see here on the chart, there are a number of comparisons to be made. I ran this on my own machines using the Southwest Technical 4K and MITS Altair 1.1, Technical Systems Consultants 10K Basic, which was cassette-based. This is not the one that appears with Flex. And at the bottom, I used Enhanced Basic, what I like to call A Basic, and ran that on my GS6, a 6502 machine that I built this summer. So, clearly, when you look at accuracy, what we have right here is probably, other than the IBM machine, in fact, not probably, certainly, other than the IBM machine, this is the most accurate Basic you're going to get in terms of what it can do. IBM 5110, far and away more accurate. But also, its random number generator sucked, pretty much. When you take a look at how much time it took for the Southwest Technical machine to run this benchmark, it's insane, really. Almost 19 minutes. I'm just crazy. Very, very accurate, but very, very slow. And, you get a reasonable amount of accuracy, say, on the Commodore PET. TSC's 10K Basic is pretty good. A Basic's pretty good, too. The NEC machine, the 8001 was great. And, MITS Altair Basic, it's okay. It's all right. And all the randomness factors are well within spec. And, anything under 30 is going to be just great for any game or anything you're doing. We don't have a sine function in 4K Basic, so we will write one, and here it is. Of course, if we have sine, we can do cosine, we could do tangent, so we've got some trig stuff we can work with. Let's run it and watch it do its thing. Ooh, that'll be handy to turn on the caps lock. And so we go. Already just looking at 30, we can tell that there's a slight accuracy problem here. Not too bad, though, when you think about it. 90. And 150, which should be just plain 0.5. And 180, which should be 0, but is essentially 0 if you move that decimal over 7, 8 places. And now here's the exact same program for the Commodore 16 using the sine function. Very typical for all Microsoft Basics. They're all pretty much the same. And you're going to notice the speed difference right away. Boomsies. Done. And we can put both of them up on the screen and take a look at the accuracy. Here we have a shot of results from both of them and some values from my desktop calculator in Linux. And the results are all pretty good, and quite frankly, Southwest Technical 4K Basic does a really good job, albeit slowly. And of course, it is more than capable of playing games. Ooh, let's change our terminal character set to 850. And here we go. Let's play. There. Well, let's remove the 8. Oh, one number. Take out the 8. And the 8 is gone. Doubles. Now we'll take out the 2 and the 6. And so on and so on.
Hi, future me here. There's something I forgot to put in the video, so I'm going to wedge it in here at the end. This has to do with the print statement in Southwest Technical's 4K Basic. The way Bob had set it up was that, if you'll read down here at the bottom of this bit from the documentation, if the next position to be printed is greater than or equal to position 48, then a carriage return and line feed is given before the next value is printed. Well, that's fine, but that also applies to text strings. If there is a space, say your text string is 60 odd characters long, and there's a space somewhere after the 48th position on the screen, it will print a carriage return and a line feed before it prints out the rest of your string. That's not very good. We need to fix that. Luckily, we have the source code. So let's take a look at that real quick. Here we are in the output area of the print routine. And what we have here is, let's see, we are looking for, right down here, finish line, and we're looking for the compare register B to the decimal number 48, or hex 30. That's our 48th spot that we're checking for. If we change that to hex 40, that should give us 64 spots, 64 characters before it looks to break the line with the carriage return and line feed. Way better. And that's going to handle just about everything we do, because typing a line number and typing print counts against you in your 72 per line. So what we're going to do is show you how it looked before and how it looks after we fix it. What we've got here is a line of program that will take up exactly 72 characters. That's our maximum. Pop that in. It's there. Looks fine. Okay, if we don't put the patch in, here's what we get when we run this. Not so good. So let's go ahead and patch it by using the patch command first. All right, now what we're looking for is somewhere around memory location OCF0. And why I say around, because we're running version 2.0, and the book, in the Best of Information Age, has version 2.1 in it. So there's going to be a few little changes, but it should be around here somewhere. Let's take a look. Let's start looking around OCF4. Okay, there's a JSR instruction, 0276. Aha, okay. So that is OCF7 in our 2.1 source code. So let's just keep looking. 32, pull A, 32, push B. We're in the right place. We're loading A with something. There's our increment. Compare B with hex 30. Let's change that to 40 and then see what we get. Done. Let's see, a little warm start. Should get us back to where we were. It does. A much better result, don't you think? Hey, thanks for watching the 6502 show. It's always my pleasure to bring it to you. I hope you had a good time. I sure did, putting the video together. If you like it, hit the like button. You can subscribe and all the other good YouTube things. So any software, anything we've talked about today, it's on my website in the description. Just you can go check it out, and there's ways to contact me there too if you wish. So until I see you again next time, y'all take care.